Imagine two tiny particles, so small that no microscope could ever see them. They are born together from the same flash of energy, like twins emerging from a cosmic womb. Then, these particles drift apart. One might stay here on Earth, and the other could be sent to the farthest corner of the universe. And yet somehow, mysteriously, no matter how far apart they are, these two particles remain connected. Change one and the other changes instantly. Instantly, faster than light, faster than anything in the universe should move. That's quantum entanglement, one of the most mind-bending, reality-shattering ideas in physics. But before we dive in, let's be honest, quantum mechanics sounds intimidating. It feels like something only scientists in white coats or genius mathematicians could ever truly grasp. But here's the truth. You don't need a PhD to understand the essence of it. You just need curiosity, imagination, and a willingness to question everything you've ever believed about reality. Because quantum entanglement doesn't just challenge physics. It challenges the way we think about existence itself. So, let's start from the beginning. In the early 20th century, physicists discovered that the universe doesn't behave the way we expect when we zoom in to the atomic and subatomic levels. Newton's laws, the kind that explain why an apple falls or a car moves, simply fall apart. Instead, we enter a strange world of probabilities, waves, and uncertainty. A world where things can exist in many states at once, until we look at them. That's the famous observer effect. The idea that the mere act of observing something changes its reality. But entanglement takes this to an even deeper, almost mystical level. Let's imagine you have two playing cards, say, a red and a black one, face down. You don't know which is which. You take one to New York, and your friend takes the other to Tokyo. When you flip yours and see red, you instantly know your friend has black. No big deal. It's just logic, right? But in quantum entanglement, it's not just that one reveals the other. It's that the act of measuring one creates the reality of both. Before measurement, neither card has a defined color. Both exist in a blurred state, a superposition of being red and black at the same time. Only when one is observed does the universe choose, and the other instantly reflects that choice, no matter the distance. Albert Einstein called this spooky action at a distance. He didn't believe it could be real. To him, it violated one of the most sacred principles of physics, that no information can travel faster than light. But in the 1960s, an Irish physicist named John Bell proposed a way to test it, and by the 1980s, experiments proved that Einstein was wrong. Entanglement was real. Particles separated by miles behaved as if they were one. Now pause for a second and think about what that means. The universe isn't just a collection of separate things bouncing off one another like billiard balls. It's interconnected. At the deepest level, everything may be entangled. Everything from the atoms in your body to the light from distant stars. And here's the wild part. Quantum entanglement isn't just a weird curiosity. It's becoming the foundation for the next revolution in technology. Scientists are using it to build quantum computers that could process information at unimaginable speeds. Others are developing quantum teleportation, where the state of a particle can be transmitted from one place to another without ever physically moving. The age of quantum technology has already begun. But beyond the science, there's a deeper question: what does this say about reality itself? If two particles can influence each other instantaneously, what does that say about the nature of space and time? Is there something hidden beneath the surface? Some invisible layer that connects everything? Some physicists believe that entanglement may not just be a feature of quantum mechanics. It may be the very fabric that holds space and time together. In other words, entanglement might be the thread that weaves the universe. Imagine that for a moment. Everything in existence connected through invisible strings of information, vibrating in harmony across space and time. The boundary between you and everything else might not be as clear as it seems. Perhaps consciousness itself, our awareness, our sense of being, is part of that same entangled web. This isn't just poetic thinking. Modern experiments are forcing us to face that question. Scientists have entangled not just photons but atoms, molecules, and even tiny mechanical objects, things that exist at the edge between quantum and classical worlds. Every time, the results are the same. Distance doesn't matter. The connection holds. It's as if the universe whispers a quiet truth through every experiment: separation is an illusion. And that idea, that everything is connected beyond space and time, isn't just scientific. It echoes ancient philosophies from every corner of the world. From Buddhist teachings about oneness to the idea of Brahman in Hinduism, or the Stoic view that we are all fragments of one universal whole. Quantum entanglement might be physics catching up with wisdom that humanity has known intuitively for thousands of years. So, what do we do with that knowledge? Do we treat it as just another strange fact, or do we let it change the way we see life, relationships, and meaning? Because if the universe truly is entangled, if the smallest parts of reality can remain connected no matter how far apart, then maybe the same principle applies to us. Maybe the connections we feel, love, empathy, intuition, aren't just emotional coincidences, but reflections of something deeper, something woven into the universe itself. And that's where the real beauty of quantum entanglement lies. It's not just a scientific mystery, it's a window into who we are. Let's go back to that idea: two particles born together, then separated yet somehow still linked. The big question scientists have wrestled with for a century is, how? How can one particle know what happens to the other instantly, even if they're light years apart? To understand this, we need to take a closer look at the rules of the quantum world, rules that sound more like magic than science at first. In the everyday world, we're used to things having definite states. A light switch is either on or off. A coin shows either heads or tails. But in the quantum world, particles don't follow those rules. A quantum particle, like an electron or photon, can exist in a state of superposition. That means it's not just here or there, it's here and there at the same time. Not spinning up or down, but both. Not moving left or right, but in all directions until it's measured. When two particles become entangled, their superpositions become intertwined. They share a single quantum state, one that can't be described separately. It's like having a pair of dice that always add up to 7, no matter how far apart they are. If one rolls a 2, the other must roll a 5. But in the quantum version, neither die actually decides its number until you look. And the moment you do, the other instantly locks in to match the total. But what connects them? What invisible thread ties their fates together? Einstein thought there must be some kind of hidden variable, a secret mechanism beneath quantum physics that determines the outcome in advance. To him, quantum mechanics was incomplete. There had to be something missing, something classical, something logical. Then came John Bell. In 1964, he came up with a brilliant way to test whether Einstein was right. Bell designed an experiment that compared the statistical correlations between entangled particles. If hidden variables existed, the results would stay within certain limits, called Bell's inequalities. If they didn't, the results would break those limits. And when scientists finally ran the tests, the results shattered Einstein's view. The correlations between particles were stronger than any hidden variable theory could explain. The only possible conclusion: quantum entanglement was real, and the universe doesn't play by classical rules. Over the next decades, these experiments got more precise, closing every possible loophole. In 2015, a group of scientists performed the first loophole-free Bell test. They entangled electrons in diamond crystals separated by more than a kilometer. Detectors measured their spins at precisely synchronized moments, making it impossible for any signal to travel between them, even at light speed. And yet, their results were perfectly correlated. This meant that entanglement wasn't an illusion or a flaw in the setup. It was a fundamental property of reality. Now, what's truly stunning is how humanity has started to use this phenomenon, not just to prove it exists, but to harness it. In the field of quantum computing, entanglement is the secret ingredient that allows quantum bits, or qubits, to perform multiple calculations simultaneously. While a regular computer bit can only be a 0 or a 1, a qubit can be both, thanks to superposition. And when qubits are entangled, their states become linked, allowing computations that grow exponentially faster than anything a classical computer can achieve. That's not just theory anymore. Google, IBM, and dozens of research labs have built early quantum processors. In 2019, Google claimed quantum supremacy, performing a task in minutes that would take the best supercomputers thousands of years. Though the debate continues over how practical that experiment was, the message is clear: quantum technology is no longer science fiction. Then there's quantum communication, which uses entanglement to transmit information securely. In traditional communication, a message can be intercepted or copied. But quantum information changes the game. Because observing a quantum state collapses it, any attempt to eavesdrop would instantly destroy the entanglement and reveal the intrusion. It's the foundation of what scientists call quantum encryption, an unhackable way to send data. In 2017, China launched a satellite named Metis, which performed quantum key distribution between ground stations over 200 kilometers apart. Entangled photons were sent from space, maintaining their correlation across massive distances. That experiment proved that entanglement can survive the journey through Earth's atmosphere and even space itself. This is the birth of what many now call the quantum internet, a network that could one day connect quantum computers across the world, enabling instantaneous and secure communication. But here's where things get even stranger. In 2017, researchers at Delft University showed that entanglement could be created between tiny diamonds. A few years later, scientists managed to entangle mechanical oscillators, microscopic pieces of matter large enough to almost be seen with the naked eye. That's like watching quantum mechanics cross over into our macroscopic world, the world we live in. The more we study entanglement, the more it seems that the boundary between the quantum and classical worlds isn't a wall, it's a blur. And that blur might hold the key to understanding consciousness itself. Now, that's controversial. Most physicists focus on measurable mathematical models, but some thinkers, including Nobel laureates, have speculated that consciousness might be linked to quantum processes in the brain. Could entanglement occur between neurons, influencing thought and perception? Could awareness itself be a quantum effect? It's not proven, but the parallels are fascinating. Entanglement defies separation. Consciousness, too, resists being broken into parts. Every neuron in your brain might fire individually, but somehow they create a unified sense of you. Some physicists, like Roger Penrose, believe that quantum coherence could exist in microscopic structures called microtubules inside neurons. If that's true, our thoughts might be connected to the same mysterious quantum field that links particles across the universe. Imagine what that means. Every idea, every emotion, every act of kindness could be ripples in a vast, interconnected sea of consciousness, where separation is an illusion and awareness stretches far beyond the body. Even if you see this metaphorically, it's powerful, because quantum entanglement doesn't just describe particles, it describes relationships between objects, people, and perhaps everything that exists. And maybe, just maybe, that's why we feel inexplicable bonds, why we sometimes sense someone's presence before they arrive, or feel connected to people far away. Maybe those aren't coincidences. Maybe they're echoes of a deeper physical truth. The universe, as entanglement shows us, isn't made of isolated parts. It's a continuous dynamic web. Every atom in your body was once part of a star, entangled through cosmic processes billions of years ago. In that sense, you are literally made of stardust. Not metaphorically, but scientifically. So when we talk about understanding quantum entanglement, it's not just about physics. It's about understanding our place in the universe. It's realizing that we're not observers standing apart from reality. We are reality observing itself. That's the beauty, the terror, and the mystery of entanglement. It collapses the distance between there and here. Because when two particles share a connection that transcends space and time, it whispers a simple but profound truth. Maybe everything does. Now that we've journeyed through the science and mystery of quantum entanglement, one question remains: what does it mean for the future? Because entanglement isn't just an abstract concept anymore. It's becoming the foundation of a new reality, one that could transform every field of human knowledge. From communication to computing, from medicine to our very understanding of existence, entanglement is quietly rewriting the rules. Let's start with technology. Imagine a world where communication happens not through radio waves, fiber optics, or satellites, but through quantum channels, instantaneous, unbreakable links across any distance. With entanglement, messages could be transmitted not by carrying signals through space, but by correlating states between distant systems. No delay, no interference, no possibility of interception. Right now, researchers are already building quantum repeaters, devices that maintain entanglement over long distances, allowing for a global quantum internet. A future network built on entangled particles would be faster, more secure, and far more powerful than anything we can imagine today. Governments and tech companies around the world, from the US to China to the EU, are racing to make it a reality. But the implications go far beyond data. Quantum teleportation, yes, real teleportation, is another area that uses entanglement. It doesn't move matter itself, but it transfers the state of one particle to another, effectively recreating it somewhere else. In a sense, the information that defines a quantum system can jump across space, guided by entanglement. Scientists have already achieved teleportation over distances of hundreds of kilometers, and experiments on the International Space Station aim to extend that even further. Now imagine what happens when we scale that up. When we can teleport not just particles, but entire quantum systems. It's not about Star Trek-style transporters yet, but it's a step towards something profound: the ability to move information instantaneously, without crossing the space between. And that brings us to perhaps the most mind-expanding idea of all, that space and time themselves might emerge from entanglement. Some physicists now believe that space-time isn't fundamental. Instead, it's a construct, a kind of illusion that arises from the web of quantum entanglement connecting everything. Think of it like a spider's web. The threads are the entangled connections, and what we perceive as space and geometry are simply patterns created by those threads. This idea has gained traction in the field of quantum gravity, the attempt to unify Einstein's relativity with quantum mechanics. In this view, entanglement doesn't just happen in space, it creates space. Without entanglement, the fabric of the universe might literally fall apart. If that's true, then everything, every star, every atom, every heartbeat, is woven from the same invisible network. The cosmos isn't a vast emptiness dotted with objects, it's a single, continuous field of relationships, and what we call reality is just how those relationships appear from our perspective. That's the scientific side. But there's also a human one. If entanglement is the foundation of reality, it changes how we see ourselves. For centuries, science and philosophy have told us we're separate, individuals existing in isolation, observers standing apart from the world. But entanglement suggests something radically different. We're all connected at the deepest possible level. When you think, speak, or act, you're not just moving atoms in your own little corner of the universe. You're influencing a system that stretches far beyond what you can see. Every choice ripples through the field of reality, echoing in ways we might never fully understand. It's no wonder that artists, philosophers, and spiritual teachers are drawn to this idea. The notion that everything is one, once seen as mystical, is now echoed by the mathematics of quantum mechanics. Take the famous double-slit experiment, one of the simplest yet strangest demonstrations of quantum behavior. When a single particle passes through two slits, it acts like a wave, interfering with itself, as if it traveled through both slits at once. But when it's observed, it behaves like a particle again. It's as if reality only chooses a form when consciousness interacts with it. Now, combine that with entanglement. The act of measurement doesn't just affect one particle. It can influence another light years away. It's as though observation, awareness, isn't local. It's part of a universal process. That raises an astonishing possibility. Maybe consciousness itself is entangled. Maybe every mind is a reflection of a single universal awareness, fragmented into individual perspectives. This doesn't mean physics has proven spirituality, or that science has suddenly turned mystical. It means that at the deepest level, the boundaries we draw between physics, philosophy, and consciousness are starting to blur. And in that blur, something extraordinary emerges. A new way to understand existence, not as a machine, but as a living, interconnected whole. Think about it. For thousands of years, humanity has searched for unity, in religion, in art, in science. Entanglement might be the bridge that finally connects them. It's a reminder that what happens in one part of the universe can affect the rest, that nothing exists in isolation, and that connection, not separation, is the true nature of reality. The implications reach even further. If we apply entanglement to biology, we might uncover how life organizes itself. Some researchers believe that quantum coherence could play a role in photosynthesis, allowing plants to transfer energy with near-perfect efficiency. Others think it might explain how migratory birds navigate, using Earth's magnetic field, through entangled electrons in their eyes. And in the future, quantum biology could unlock new frontiers in medicine, from understanding how DNA repairs itself to how our brains process information. Every discovery points to one truth. The quantum world isn't somewhere out there. It's here, inside us, shaping every atom of our being. So where does this leave us? Maybe the ultimate lesson of quantum entanglement isn't just scientific. It's philosophical. It tells us that the universe isn't a collection of objects, but a network of relationships. That what we call self and other are different expressions of the same underlying reality. And maybe, just maybe, understanding that could change how we live. If everything is connected, then compassion isn't just moral. It's logical. Empathy isn't just emotional. It's fundamental. Because when we harm another, we're ultimately harming a part of ourselves. That's the quiet message hidden inside the equations of quantum mechanics. Beneath all the math, all the experiments, and all the mystery, it whispers something profoundly human. You are not alone. The light that travels across galaxies, the particles that spin within atoms, the heartbeat that echoes in your chest, all of it is part of the same song, the same field, the same infinite pattern of entanglement. And when you look up at the night sky and feel that strange sense of wonder, That feeling that somehow, in some way, you belong to all of this. That's not just emotion. That's truth. Quantum entanglement isn't just the science of connection. It's the poetry of existence itself. So the next time someone tells you that physics is cold or impersonal, remember this: at the deepest level of reality, everything, every person, every planet, every photon, is connected in ways that transcend space and time. And if you truly understand that, then you've already understood quantum entanglement.